Hi, and welcome to 8th grade science with Miss Lano. Today we're going to be learning about the parts of waves and how they can impact different amounts of energy. The instructional strategy we will be using today to determine the parts of waves and their different variations of energy is computer-based learning through the application called Gizmos. We've done some Gizmos before, so we're going to revisit that program and work through a simulation that deals with waves and its components. Alright class, let's get started. For our introduction, we'll review what we're going to do today. Today you will learn more about waves and their components. Remember, we are going to relate these ideas to the energy. Looking at the two pictures below, which wave has more energy and how can you tell? The wave on the left is on a very calm day, and you can see that the wave height is not that great. You have little waves coming, but the water isn't moving that much. When you look at the wave on the right, you see a large wave height, big crests, giant pieces of foam, and a surfer actually riding on the wave. So thinking about it, which wave has more energy? The wave on the right has a lot more energy because it can move so many more particles. Now we're going to learn specifically what the parts of this wave is called and how it can impact the energy. Now this brings us to our gizmos. In this program, you need to make sure that your type of wave is transverse and hit the play button. From here, you can start to see that there is a transverse wave in rest position. You have a high point, a low point, and another high point. This is a very medium amount of energy. It's not too high, it's not too low, and there's a lot of space in between each high point. This right here is a transverse wave in rest position. Looking at your graphic organizer, you can start to begin labeling your diagram. Looking at this wave, you can see that it is a transverse wave in rest position. Now fill in this component in your graphic organizer. Now that you have labeled your wave in a standard rest position, I want you to look at the high and low parts of the waves again. These are called your crests and your troughs. Thinking about that, when you're at the beach and you see a wave gently lap across the shore, you can say that the wave is cresting on the beach. That's why the top part is called crest. A way to remember that the bottom part of the wave is called trough is by thinking about how farm animals eat from food at a trough below them. So crest is at the top and trough is at the bottom. Now we can label the crest and the trough on our graphic organizer. This part is called the crest, the top of the wave. This is called the trough, the bottom of the wave. Think about how these could impact wave energy. The higher the crest, the more energy. The lower the crest, the less energy. Same goes for trough. Back to the gizmo, I want you to look at the distance between two crests or two troughs. If we pause this here, you can see that it has a large length in between the wave. If we increase our frequency, you can start to see that there is a smaller distance in between. Waves that have a shorter wavelength have more energy. Now that you know what the distance is between two crests or two troughs, you can label the wavelength in your diagram. The bigger the wavelength, the less energy. The smaller the wavelength, the more energy. Now I want you to look at the height of the wave. The height of the wave is calculated by the midpoint to the crest or the midpoint to the trough. The larger height that you have, the more energy. The smaller height that you have, the less energy. If we turn up the amplitude, that gives us a really big height. So amplitude means height. Back to your graphic organizer, you can now label the amplitude. Remember that amplitude is the height of the wave, and it is measured from the midpoint to the top of the crest, or the midpoint to your trough. Now it's time to review. You've learned about waves and their components. How can we relate these ideas to energy? Looking at the wave on the left, it has not a lot of energy. That is due to its small amplitude and really long wavelength. If you look at the wave on the right, it has a lot of energy. It has a very high amplitude and a very short wavelength. I hope you've enjoyed learning about the parts of waves and how they impact their energy. Have a nice day!